The boiling points of these compounds increase steadily from methanol to pentanol. Which type of intermolecular force is primarily responsible for the steady increase in boiling points from methanol to pentanol? Let us observe the intermolecular forces that are present in each of these molecules. All the compounds have hydrogen bonding due to their OH minus groups. Therefore, all compounds have hydrogen bonding due to their OH minus groups. However, the steady increase in the boiling points as we go from methanol to pentanol is mostly because of the London dispersion forces. We know that as molecules get bigger, there are more electrons which create a stronger temporary attraction. Between the molecules. This makes it harder for the molecules to separate. Therefore, the boiling point increases. Because London dispersion forces are directly proportional to the size of the molecules. Therefore, larger molecule, stronger London dispersion forces, which give us higher boiling points. Here, the molar mass for methanol is 32.04 grams per mole. For ethanol, it's 46.068 grams per mole. For propanol, it is 60.095 grams per mole. For butanol, it's 74.12 grams per mole. And for pentanol, it is 88.1482 grams per mole. Therefore, the London dispersion force, or the intermolecular force, increased as the molecules were larger. Therefore, this explains the higher boiling points of the molecules from methanol to pentanol. Question 53. CF2H2 has been considered as a replacement for CF2Cl2. The boiling point for CF2H2 is minus 56 degrees Celsius, and the boiling point of CF2Cl2 is minus 29 degrees Celsius. Which of the following statements concerning these two compounds is or are false? Let us look at option A. Option A states that CF2H2 exhibits hydrogen bonding intermolecular forces. This statement is false because hydrogen in the molecular geometry of CF2H2 does not directly bond with the fluorine. For hydrogen bonding to occur, hydrogen molecules need to bond with highly electronegative atoms NOF. For example, water, HF, or NH3. Therefore, statement is false because hydrogen does not directly bond with fluorine, and instead it bonds with carbon. Option B. Both compounds are gases at room temperature. This statement is true. The reason is both of the boiling points are below room temperature, that is 20 degrees Celsius. Therefore, both compounds should be gases. At room temperature. Option C. CF2Cl2 exhibits stronger London dispersion forces as compared to CF2H2. This statement is true because CF2Cl2 is larger than CF2H2. This means it has greater polar which leads to stronger London dispersion forces. Option D. Overall, CF2Cl2 exhibits stronger intermolecular forces as compared to CF2H2. This statement is true because CF2Cl2 has a higher boiling point compared to CH2F2. CF2Cl2 has a boiling point of Yes, CF2H2 has a boiling point of minus 56 degrees Celsius, which is less than the boiling point of CF2Cl2, which is minus 29 degrees Celsius. Therefore, it has stronger intermolecular forces. Option E. Both compounds are polar, so both compounds exhibit dipole-dipole forces. This statement is true because in the molecular geometry of both compounds, we can see that there is an uneven distribution of charge. Therefore, compounds exhibit dipole forces. The next question is 111. Carbon tetrachloride CCl4 has a vapor pressure of 213 torr at 40 degrees Celsius and 836 torr at 80 degrees Celsius. What is the normal boiling point of CCl4? We're going to use this equation for this problem. Let us state what is given. Vapor pressure 1 is equal to 213 torr. Temperature 1 is equal to 40 degrees Celsius. We need to convert this into Kelvin, which is 313 Kelvin. Vapor pressure 2 is equal to 836 torr, and temperature 2 is equal to 353 Kelvin, which is 80 degrees Celsius. Let us plug in these values in the equation. Ln 213 torr upon 836 torr is equal to the enthalpy of vaporization upon R constant. Temperature 2 is 353 Kelvin, and temperature 1 is 313 Kelvin. Here, we need to find the enthalpy of vaporization since it is not given to us, and after which we will use the value of the enthalpy of vaporization into the next equation, which will give us the normal boiling point of CCl4. Let us calculate this part. We get ln 0.255 equal to enthalpy of vaporization and the gas constant value, which is 8.3145 joules per mole Kelvin. Let us calculate the temperatures. We get 0.02 0.0283 minus 0.003195. ln 0.255 is equal to negative 1.366 If we subtract these two, we get 0.000362. Let us calculate for the heat of vaporization, and we get heat of vaporization equal to 31,372. .71 joules. Now let us calculate the normal boiling point. For this equation, the temperature, the T1, is the same. The pressure is also the same for P1. However, T2 is the one that we are searching for, and P2 will be 760 torr, because we know that the boiling point is the temperature at which the vapor pressure of a liquid becomes equal to the atmospheric pressure, therefore 760 torr. Let us plug in the values in the equation. That is P1, P2. We found the enthalpy of vaporization, which is 31373 joules per mole, the R value is 8.3145 again. And T2, and we have T1, which is 313 Kelvin. Let us solve for this part. We get ln equals to 0.255. Oh, sorry. Ln equal to 0.280 equal to let's solve this. We get 3773.2 and we get 0.003195. ln 0.280 is equal to 1.273, negative 1.273. Let's multiply these values. We get 3773.2 on T2 equal to 10.785. T2 is equal to 3773 by 10.785. T2 is equal to 350 Kelvin. Let us convert it from Kelvin to Celsius. We get 77 degrees Celsius, which is the normal boiling point for CCl4. Let us look at the next question. We have an ice cube tray containing enough water at 22 degrees Celsius to make 18 ice cubes that each have a mass of 30 grams. The tray is placed in a freezer that uses CF2Cl2 as a refrigerant. The heat of vaporization of CF2Cl2 is 158 joules per gram. What mass of CF2Cl2 must be vaporized in the refrigeration cycle to convert all the water at 22 degrees Celsius to ice at minus 5 degrees Celsius? The heat capacities for water, solid and H2O solid and H2O liquid are 2.03 joules per grams degrees Celsius and 4.18 joules per grams degrees Celsius respectively, and the enthalpy of fusion for ice is 6.02 kJ-mole. We are given 18 ice cubes at 30 grams each. With this information, we can find the mass of the ice cubes, which is equal to 18 into 30 grams. That gives us 540 grams of ice cubes. Now, let us draw the chart that represents this problem. We have 5 degrees Celsius, 0 degrees Celsius, and 22 degrees Celsius. We are converting all the water from 22 degrees Celsius to ice. Therefore, this is the chart. Let us mark Q1, Q1, Q2, Q3, and Q2. Let us write the information that is given to us. We are given the heat of vaporization is equal to 158 joules per grams. We're given the heat capacities for H2O solid, which is equal to 2.03 joules per grams degrees Celsius. The heat capacity of H2O liquid, which is 4.18 joules per grams degrees Celsius. And we are given the enthalpy of fusion, which is equal to 6.02 kilojoules per mole. Let us calculate Q1, which is equal to mass into specific heat and delta T. The mass is equal to 540 grams. The specific heat of Q1 is equal to 4.18 joules per gram degrees Celsius into the delta T, which is final initial final equal to final minus initial temperature, which is equal to 49.74 kilojoules. Let us calculate Q2. Q2 is equal to heat of fusion into moles (6.02 kilojoules per mole into 30 moles which is from the mass of ice cubes. Is equal to 180.6 kilojoules. Let us calculate Q3, which is equal to mass of ice, specific heat of solid into delta T, (540 grams) into specific heat 2.03 joules per grams degrees Celsius into final minus initial temperature. This is equal to minus 5.62 kilojoules. The total heat lost is equal to Q1 plus Q2 plus Q3, which is equal to 235.96 kilojoules. Now, the heat gained by CF2Cl2 is equal to the heat lost by the system, which is the heat of vaporization into the mass of CF2Cl2 vaporized. That is, the heat gain is equal to heat of vaporization into mass of CF2Cl2 vaporized. Therefore, the mass of CF2Cl2 is equal to 235.96 kilojoules by the heat of vaporization, which is 1558, into 10 raised to negative 3, since it was in joules, and we need to convert it into kilojoules per grams. Let us calculate this, and we get 1.5 into 10 raised to 3 grams of CF2Cl2. Therefore, amount of CF2Cl2 vaporized is equal to 1.5 into 10 raised to 3 grams.